Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'll be talking about joins in PySpark. So first of all, first question is why joins are required? Joins are required to combine data from two or more data frames based upon the common data. So what's the reason why we have to combine data from one or two tables, right, or one or two data frames? I'll give you a simple example. Let's suppose we have to find the employee who's living in a city, New Delhi. The employee information is in one table and the city information is another table. So in this case, I have to join two tables or join two data frames to get the required information. Without join, I can't get the information. It means in order to solve this query, I have to join two data frames. Simple thing is, if the data is not available in one data frame, we have to combine, we have to apply a join so that we can get data from other data frame. This is called join. So if you are from the SQL background, you already know familiar with the join. So in the PySpark, we have a almost similar type of joins except some exceptions, okay, or a syntax is different or a little bit some terms are different, but otherwise it's almost the same. So what are different type of joins we are having? First of all, I'll be showing some theoretical information, then I'll be going with the practical information. So in this case, you can see different type of joins are, the very first join is inner join. Inner join meaning is a join which returns the rows have a matching keys in both data frames. It means it is a common thing. You can see in this Venn diagram, it is a common thing. It's called inner join. Then we have a left join. Left join meaning is data from the left data frame or table plus the inner join. So it is a inner plus left. Right join meaning is it is inner plus right. Then we have a full outer join, meaning is it's complete. You can see everything is shown here. It's a complete join, means left plus inner plus right. Then we also have some other type of joins available as well, like left semi. Left semi meaning is returns only the rows from left data frame where the match exists in the right. This is called left semi. It means left table, if we are looking for the left data frame where the match exists in the right. Left anti returns only rows from the left data frame where there is no match in the right. Okay, it is left anti. Then we have a Cartesian product or cross product. It's simply simple logic is, if we the first table is having 4 rows, second table is having 3 rows, so the Cartesian product will be 12. It means it will be all the possible combinations which are be having, it will be returning that, which is the, in this join we don't use that often because it's give you unnecessary results, right? So this is the type of joins we are having. Now let's come to the PySpark. I've already have opened up the PySpark in front of you. So in this PySpark, we'll be now a little bit will be showing the demonstration in a precise way, so that you can get the information with the simplest examples, right? Let's get started. So first of all, in order to apply joins, we have to first load the data. So I'm having a data available in the two CSV files which represent two tables or two data frames. Let's do it. First data frame, I'll be naming it as df1. So I'll be using spark.read.csv, in which I have to give the data frame location. It's available in my D drive. Okay, it's D drive, it's a j1.csv. We have to specify these additional information like header true and infer schema true. Infer schema equal to true. So header true meaning is I have to include the first row. I'll be considering the first row as a column name. Infer schema true meaning is it should automatically infer the schema or sense the schema of a data. Okay. So what we have in df1. df1, let's see with the show. This is the df1. I'm having employee ID, name, department ID. Let's see the second data frame as well. It's in the same location with the name j2, and I'll be naming it as df2. Okay. Now let's see what we have in df2. So in a df2 we are having department ID and department name. Now in this case, one thing is common we have kept, which is department ID. So based upon department ID, we'll be combining both the data frames. So let's get started. The very first type of join which I'm going to apply is, it's called inner join. Okay, it's very simple. Let's do it. So very first way is we can do in this way: df1 dot join. Okay, join keyword, then df2 straight away dot show for printing the results. So the syntax is very simple: data frame 1 dot join data frame 2 dot show. Let's see what kind of information we are getting if we are pressing enter here. In this case, I'm getting not the information which we are looking for, because it's almost like a cross join. You can see we have a duplicacy also available, like department ID is coming 2 times and we are having unnecessary rows available. So it's not the join we were looking for. So how to get rid of this, or how to solve this problem? We can solve this problem by using another type of syntax which we can use. We have two methods I'll be showing you. First method is we can specify the common column. Okay, so in this case what we can do is we can write here df1 dot department ID, the common column, equal to department df2 dot department ID, because department ID is common in both data frames, right? So in this case, plus, because that this department ID is coming 2 times, so what we can do is we can also write here drop the extra column. Drop what? We can write df2 dot department ID. This we can do. Okay, let's see. So this is what we were looking for, because in this case only two things are common. 101 ID and 102 ID are common in both, right? That's why we were expecting only 2 rows, but in the previous result it was showing unnecessary data, which was somewhat like a cross join. So this is the one way. Other way we can also use, it is the another syntax we can use. What's other syntax? It's up to you which one you want to use. This is the one way. It's a little lengthy. Other way is what we can do is df1 dot join df2. Afterwards we can use two options. First is on clause. In on we can specify the common column, which is the department ID, and second one we can use how equal to inner, okay. In this case we get same result. You see this query is shortened one, right, and which give us the same result as of previous query. This is how the inner join can be done, right? In the same way, let's now do the second type of join. It is nothing but the left join. So I'll be using this syntax now because it's simplified, although you can use other type of syntax as well, which I can show you. I'll be now showing both the type of syntaxes which we can apply here. First is left. In this case, same thing. In the how, we are just specifying the left here instead of inner. In the left join, what happen is you can see it will be inner join. You can see the result is same. The first two rows are coming. It means is the inner join plus data from left table, and none represent there is no match in right table. That's why null is coming. Okay, we have seen in the Venn diagram. So inner the left joins indicates inner join plus matching plus the data from left table. So why null is coming here? Because correspond to those in the left table, there is no matching in the right table. That's why we're getting null here. Is it okay? So in this case, how we decide which is the left or one? This is our left table, df1. This is a df2 is a right table. So df1 we are keeping it as on the left, so that is the left table. Df2 is a right table. So it is the inner join plus data from the left table, which is the df1. So df1 include what? df1 include employee ID and name. In this case, you can see employee ID is complete because data is coming from left table, okay, and name. But the data which is coming from right table is showing null because there is no corresponding entries available, right? So this is the left join. So we can do the same thing with a little bit like bigger syntax. How we can do it? We can do with the help of this one. Okay, the same. Here we can specify comma left. Just see same result. Okay, we have a same result available. This is another way we can do it. Okay, another way we can do it. So we have our two ways available. It's whatever suits you, you can go for that. Okay, let's see the right table. It's the same type of join. In this case, inner join plus data from right table. So just we have to change this keyword from left to right. It will be showing the data from the right table plus the inner join. So inner join remain same. The result from inner join remains same, but additionally you will get the data from left or right based upon the type of join you are specifying. Okay. Now let's go with the outer join. So everything is same. Now instead of right, let's write outer. So outer meaning is it is inner join plus data from left join plus data from the right join. So that's why we are getting this 5 rows. Okay, it's a outer join, means complete. Okay, first rows first we have a data from left inner join plus data from the left plus data from the right. It's called full outer or outer. Now let's go with the left semi. So what is left semi? We already discussed left semi. Left semi meaning is returns only the left data frame rows, okay, that match the right data frame. So how we can do it? Same way, instead of outer, now we'll be using left semi. Okay, that's it. This is the one. Okay, it's a left semi. Now let's go with the left anti. What is left anti? Returns only the left data frame rows that don't match right data frame. So it is left anti. Okay, another one. Right, this is the left anti. Right, and last type of join which we can now with which the video will be ending, it is called as a cross join. Very simple. df1 dot join. Okay, df1 dot, I'll be writing cross join, J capital, cross join df2. Okay, straight away dot show. It means what is Cartesian product or cross join? It will show you everything, all the possible combinations. Okay, all the possible combinations. So how many rows we are getting? 3, 6, 9, 12. Why 12? Because originally my two data frames were having 4 and 3. 4 into 3 is 12. That's why it's showing 12 rows. So I hope you must have understood from this short little video how we can make use of joins in PySpark. If you have any question, please feel free to ask to comment on this video. Right? Please ask your queries and post the comments. I'll be looking forward to it. Thanks for watching, guys. See you next video.